Oxides and hydroxides. As I said, the boron or 13th group element, it forms oxides of the formula M2O3 and hydroxides of the formula MOH thrice. And if you look at its acidic character, BOH thrice, it looks like basic compound, but it is not basic because of presence of boron oxygen hydrogen bond. Here the bond pair it shift towards oxygen and there is the liberation of H plus, therefore acidic in nature. And boron, it is a non-metal, therefore as you know, non-metal oxides are always acidic. Therefore both boron hydroxide as well as oxides are acidic in nature. And aluminium hydroxide and aluminium oxide amphoteric in nature. And aluminium, that is the diagonally related to magnesium, and hence it shows amphoteric it is diagonally related to beryllium, and hence it shows amphoteric in nature. And gallium hydroxide and gallium oxides, so these are also amphoteric in nature, whereas indium as well as thallium hydroxides and oxides, they are the basic in nature because these are all metal hydroxide and as well as metal oxides. Boron is a non-metal and it is a bad conductor of electricity, whereas the aluminium is a metal and good conductor. Boron is hard, but aluminium, it is a soft metal. And aluminium, whenever it reacts with oxygen, immediately it forms aluminium oxide, Al2O3. And Al2O3 means a formation of passive layer on the metal of aluminium, and it can prevent the further corrosion. Therefore, we call it as passive layer or the self-protection. And boron exists in two form, that is crystalline and amorphous, and aluminium does not exist in different form. See, you can see different anomalous properties, a number of anomalous properties for boron. Boron, it is a non-metal and all other group elements are metallic in nature, and boron, it is a hard metal, hard element, whereas other elements are always smooth elements, and boron crystalline and amorphous, whereas aluminium, it cannot show in the different allotropic form. And all other elements of 13th group except boron, they are very good conductor of heat and electricity, whereas boron, it is a bad conductor. The reason is, one is non-availability of d orbital, and another reason is small atomic size, and hence its electronegativity is very high. The melting and boiling point of boron are much higher than that of aluminium, again because of small atomic size, and boron forms only covalent compounds, whereas aluminium forms even some ionic compounds. If I consider aluminium fluoride AlF3, it possesses more ionic character, and if I consider Ali3, it possesses covalent character. And whereas if you consider boron, fluoride BF3 and Bi3, and if you look at the nature of these two elements, both boron and fluorine, these are non-metal, so it results more covalent character, whereas it possesses partial ionic character also because of small ionic size of fluorine. So BF3, it is actually a covalent compound, and however it possesses little percentage of ionic character also. And Bi3, it is one of the pure covalent compound.